In this lecture, we are going to discuss the working of bubble sort with an example. Before we get into the example, we should know few things. Bubble sort take passes to complete its operations. And we have to remember one thing. If a of j is greater than a of j plus 1, then perform swap. By having these 2 points in mind, we'll go to the example. So this is the given input 32, 13, 11, 25, 14. So here n it is 5. Okay. Now we'll see how the bubble sort works. We should compare a of j with a of j plus 1. So as per this example, we have to compare 32 and 13. So let us compare 32 and 13. Is 32 greater than 30? True. If it is true, then what we have to do? Swap. Just compare 32 and 13. So true, we have to swap 13, 32, 11, 25 and 14. What next? You have to compare 32 and 11. Is 32 greater than 11? Yes, true. Then what we have to do? Swap. It will become 13, 11, 32, 25, 14. What next? Just compare 32 and 25. Is 32 greater than 25? Yes, true. Then what we have to do? Swap. So 13, 11, 25, 32, 14. What next? Just compare 32 and 14. Is 32 greater than 14? True. Then perform swap. What will happen here? 13, 11, 25, 14 and 32. So this is the outcome of pass 1. So 13, 11, 25 is the outcome of what? Pass 1. Now we have to take this as input for the pass 2. Now we move on to pass 2. So 13, 11, 25, 14, 32. Yes, my pass 1 gets over here. So what we have to do? The same thing. Just compare a of j with a of j plus 1. If a of j is greater than j plus 1, then swap. Just compare 13 and 11. Is 13 greater than 11? True. Then what we have to do? Swap. So it is 11, 13, 25, 14, 32. What next? Just compare 13 and 25. Is 13 greater than 25? No. Then you should not perform swap. Keep it as such. 11, 13, 25, 14, 32. What next? You have to compare 25 and 14. Is 25 greater than 14? True. Then we have to perform swap. What will happen? 11, 13, 14, 25, 32. What next? Just compare 25 and 32. Is 25 greater than 32? No. Then do not perform swap. So it remains as such. So this is the pass 2 and this is the outcome of pass 2. So by looking into this, we can see the elements are sorted. And it took how many number of passes? It took 2. So this is how the bubble sort works. Now let us discuss the code for bubble sort. It will start from 0, I equals to 0, and the loop will go up to what? Until I less than n minus 1, I plus plus. Why? Because look at this picture which is there at the right hand side. So it will start from 0th index and it will go up to what? 4. Number of elements is 5. It will go up to the position 4 because Anyways, it has to make the comparison of all the elements. Okay, let us have one more for loop. Before that, I'm just introducing a flag variable. I'll tell you why am I using after completing this. Let us introduce a flag variable, and now we are going to have another for loop, which is for j equals to 0, j less than n minus 1 minus I, and j plus plus. Okay, so inside this for loop, what we have to do, listen, we have to compare. Now we have to start comparing the elements. So what we'll be doing here, we'll be comparing, initially we'll be comparing 32 and 13, right? So in the next step, once it is sorted, we'll move on to what? 32 and 11, then 32 and 25. We keep doing this until one pass is completed. Let us write the code for that. If a of j is greater than a of j plus 1, what we have to do, we just saw, right? In the example, we'll have temp equals to a of j, then a of j equals to a of j plus, just do the swapping. I'm just writing the code for swapping, that's it. A of j plus 1 equals to temp. Swapping is done. Now I'm just making the flag variable as 1. Listen, what we are doing here is, this should be inside the if only. If the swapping is done or if the swapping has happened, then you have to make the flag variable as 1. See, we initially made the flag variable as 0 here. Okay, then now once the swapping has happened, we have made the flag variable as, the value flag variable as what? 1. This is just to represent the swapping has happened. Now coming over here, you can close the j for loop here, and what you can do is, now you can, before closing the I loop, just check one thing. If flag equals to 0, okay, you can just break, which represent the swapping has not been done. Okay, just we are doing some optimization in the code, nothing else. All these things are what? Just we are doing some optimization over here. Here flag equals to 0, then we are making it flag equals to 1. All these are way of optimizing your code. Here we have done one more optimization. Look at this j for loop. J equals to 0, j less than n minus 1 minus I, j plus plus. Why do we want to include this minus I? Why can't be just j is less than n minus 1? I'll tell you why. See, if you look at the example over here in the right hand side, at the end of first pass, one element, that is the largest element, has been moved on to the correct position at the last position. At the end of second pass, okay, the next largest element, that is 25, has been moved on to the correct position. So because of this, so every time if you reduce I by 1, that would lead to reduction in the number of times the for loop that is going to run. This is one level of optimization, because anyways at one point it is sorted, then why do we want to check it again, or why do we want to go for one more iteration which is already done by showing it is sorted, right? 32 has been moved on to the correct position, 25 has been moved on to the correct position. So to avoid this for loop running time, okay, we are just including minus I. This is another level of optimization that we have made over here. Let us discuss the time complexity. The first thing is worst case. What is worst case here? As we discussed, we can think about a reversely sorted input. We can keep this as word for worst case, a reversely sorted input. Later what will happen, listen, in a reversely sorted input, just look at the code. The first for loop, that is the I loop, anyways it has to run for what? Up to n minus 1. Start from 0 and it has to run for up to n minus 1, which is it has to run for n times. Yes or no? The first for loop, this I loop has to run for how many times? N times. And coming to the J for loop, at the worst case, we have assumed it is a reversely sorted input. So whenever we compare A of j and A of j plus 1, in the reversely sorted input, what will happen? The swapping will happen for sure for all the cases. Yes? Yes or no? So this will happen for how many times? N times. Okay? So n into n, what is that? N into n, it is order of n square. This is your reversely sorted. Like again I'm repeating, the I loop, this is I loop. This I loop anyways it has to run for n times because it has to check for all the elements. For all the 5 elements it has to check, right? Simply we cannot conclude that the elements are sorted. Even though if you have a sorted input, it has to check for all the elements at least once for every element. So if we have n elements, so 1 into n, it has to make it for n elements. Coming over here, this J for loop is inside I for loop. This J loop will run at the worst case. This J loop will run for how many times? N times. Why? Because the worst case input is it is reversely sorted. So anyways, for reversely sorted, every time you have to make the comparison and you will be doing this swapping. Okay, this swapping will be done. That will happen for how many times? N times. So this n and this n with n for n times, it is n into n, order of n square. This is your worst case. Now let us discuss about the best case. Best case is what? Sorted input is your best case. Yes or no? Sorted input is your best case. Coming to best case, what will happen here? Assume the inputs are sorted. If it is sorted input, this I loop will run for n times because it has to check for all the elements at least once. But coming to J, what will happen here? All the swapping will not happen. In the best case, no swapping will happen because already the elements are sorted. So no swapping will happen. That time the swapping will happen how many times? It will not happen at all because all the elements are sorted. That case, your time complexity would be just that forward n times alone. Similarly, average case, even at average case, what is average case? So it's between your lower bound and upper bound. That is your average case, right? Anyways, at least it has to go for n square when it comes to average case. Got it? So this is the time complexity of your bubble sort. Thank you for watching this video.